we will write equation 1. Write equation 1. Remember that equation 1 is v equals to u plus at. So I want to rewrite this equation. I can write it as v is equals to dx over dt, because change in displacement over time is the same thing as what? Velocity. Is equals to u plus at. So if I treat this as, I now treat dx over dt to be equals to u plus at, I can make dx the subject. Dx becomes u plus at bracket dt. Then what is going to happen? I will take integral. So taking integral of both sides, I'm going to have that integral ds is integral u plus at dt. So integral ds will give you x equals to, when you integrate u here, is going to give you ut, because this integration is with respect to t. So u and 1t will come out. Then when you integrate at, is going to give you half at squared. So this is the third equation of motion. Yeah, welcome to today's online tutorial. I'll be taking you on the topic equations of motion. And this topic we are going to be deriving the 4 equations of motion. And for us to do this derivation, we need to understand the concept of acceleration. And what is an acceleration? We define acceleration as the time rate of change of velocity. So we can simply write that acceleration A is change in v over time. The time rate of change of what? Velocity. So which can also be written as v minus u over t. So all our derivation will be beamed or stemmed from this very concept. So we start the derivation. We write that acceleration is v minus u over t. We make v here the subject. In making v the subject, we are going to have that v minus u equals to at, and v automatically is equals to u plus at. This is equation 1. So this is the first equation of motion. So we'll move on to derive the second one. For us to get the second equation of motion, we'll write that total distance traveled by a body is given by the average speed of the body multiplied by time. If we make t the subject, we are going to have that t is equals to 2x over u plus v. So I'm going to substitute this into equation 1. So put t equals to 2x over u plus v into equation 1. You will have that v is equals to u plus a bracket 2x over u plus v, or bracket close. Then what next am I going to do? What I will do here is I open up the bracket. When I open up the bracket, I'm going to have that v is equals to u plus 2as over u plus v. In this case, I need to remove or to clear, I need to clear the denominator here. So for me to clear the denominator there, is, and now this equals to, I repeated this. So for me to remove the denominator there, I'll be multiplying both by this. So now I have this is u plus v plus 2ax. So if if I open the bracket, I have to have v uv plus v squared u squared plus uv is equals to 2, plus 2ax. Then uv at left hand side cancels uv at right hand side. So this and this will cancel. I'm left with v squared is equals to u squared plus 2as. This is equation 2. And that represents the second equation of motion. So for us to derive the third equation of motion, we are going to rewrite, we will rewrite equation 1. Write equation 1. Remember that equation 1 is v equals to u plus at. So I want to rewrite this equation. I can write it as v is equals to dx over dt, because change in displacement over time is the same thing as what? Velocity. Is equals to u plus at. So if I treat this as, I now treat dx over dt to be equals to u plus at, I can make dx the subject. Dx becomes u plus at bracket dt. Then what is going to happen? I will take integral. So taking integral of both sides, I'm going to have that integral ds is integral u plus at dt. So integral ds will give you x equals to, when you integrate u here, is going to give you ut, because you have, this integration is with respect to t. So u and 1t will come out. Then when you integrate at, is going to give you half at squared. So this is the third equation of motion. Then there is another one we can add. Then we can add the fourth one. That is, the total distance traveled by body is equals to average speed multiplied by time. So this one can as well be regarded as the fourth equation of motion. So we have basically three main equations of motion, but sometimes we do add the fourth one, which talks about the total distance traveled by a body. So any of these equations can be used to tackle problem under motion. So let's write the 4 equations of motion we've derived so far. So the first one is, the first equation is v is equals to u plus at. That is first equation of motion. The second one we derived is that v squared is equals to u squared plus 2as. Second one. And the third one is that s, total distance traveled by body, is equals to ut plus half at squared. Equation 3. And the last but not the least, we also talk about total distance to be u plus v over 2 multiplied by t. Equation 4. So these are the 4 equations of motion, and it will interest you to know that this first equation, the parameters in the first equation is final velocity is equal to initial velocity plus acceleration of the body multiplied by time. In the second equation, we have that final velocity squared is equals to initial velocity squared plus 2 multiplied by the acceleration of the body multiplied by the distance traveled by the body. And the third one is that the total distance traveled by the body is equal to the initial speed of the body multiplied by the time taken plus half the acceleration multiplied by the time taken raised to power 2. Then the total distance traveled, also divided by s, is also given as average speed, which is u plus v over 2 multiplied by t. So any of these equations can be used to solve problems. How do you know when to use any of the equations? You have to look at what you're asked to find. In a case where you're asked to find final velocity and you're given initial velocity and you're given acceleration and time, you use this. So, but in a case where you are asked to find final velocity, that you are given the initial speed, initial velocity, and distance covered and the acceleration of the body. No time is not given, so you need to use this. So it depends on the parameters that are found in the question and the parameter that is not available. That determines the equations to use. In the next video, we are going to be looking at how to use these equations in tackling problems in physics, and it will be very interesting because I'll be solving WAEC standard questions for you. Thank you. Please, if this is the first time joining my channel, do well to share this channel to your friends